how do you know what method to use when? So the first thing I need you to do is we're actually going to start with our calculator. Now, when I say we're going to be choosing a method, I mean we're going to be choosing a method that's factoring, quadratic formula, or complete the square. So when I give you that option, I don't mean just type in your calculator and give me the answer. I mean, pick one of those three. Right now, we're only going to use graphing as a way to help us figure out what method we're going to use, but then I'll teach you some other tricks as we go through this today to know why should I use the quadratic formula or why should I use complete the square. So let's type this into our calculator to start. X squared minus 4x plus 4. That's going to be the first one we do here. So take a second and type that into your calculator. Some of us adjusted our windows yesterday for the activity, so if you need to get back to your home screen, you'll do Zoom 6. You should get a graph that looks like what's on the board. Now what we're going to do is we're going to find the zero. We're going to trace it. So this practice is solving by graphing for a second here. So if you want to do that on your own, I'll run through it real quick if you need to. You'll go second trace. Which option do you choose? 0. So we'll pick number 2. And we'll need to be a little bit to the left of that root. It looks like it just bounces off the axis. You can probably guess where it's at, but we'll review here. A little bit to the right. Enter. And enter. And double check. Do we all get the same x-intercept? That 2? What does it say? That's 2. That's 2. So when your calculator, and that is an exact answer, because mine says 2.0008. That's the reason it gives you sometimes those decimals is because your calculator, the algorithm inside the programming of it, is estimating distances between the left and right bound that you chose. So if your left and right bounds are far away from each other, like if you chose like a point up here and over here, it's going to be more of an estimate than if you chose bounds that were right next to the x-intercept. That means you probably didn't come to the right side of your x-intercept. Yeah, so just show that again. Okay, so we have an x-intercept at 2. Do I have another one or just one this time? Just one. So here, from graphing, we see that our solution from graphing is x equals 2. Now, we've done this before, so we know that that's a rational number. Can you factor a quadratic that has a rational root? Yes. Yes. So that's the first method we're going to choose. We are going to choose to solve this one by factoring. Okay? Yes, complete the square will work. Yes, quadratic formula will work. However, the best method to solve this one by hand is going to be factoring. Okay, so let's make sure that we can solve it by factoring. If I have x squared minus 4x plus 4, what factoring method should you use? Or how do you do this? You don't have to just split the middle because the leading coefficient here is 1. I mean, you could, but you're kind of guessing. You're finding two numbers that multiply to 4 and add to negative 4. Negative 2 and negative 2. Good. So how do I write that in factored form? X minus 2, x minus 2. Good. Well, the zero product law technically then says that you take each of those factors, you set each factor with a variable equal to 0. Now, we did one like this on our activity yesterday. Those are the same, but when I add 2 to both sides, what answer do I get? 2. And then I get x equals 2 over here again. We're going to learn more, I think, third quarter, maybe beginning of fourth quarter, why those show up twice. But for now, we only have one answer. We know that x equals 2, which is what we got from graphing, correct? So why was factoring the best method here? Well, why you should choose this method is because you got, I want to make sure I say this the same for both classes. Let's write it this way. When you get rational answers, so when you get a rational root, factoring will always work. And if you're good at factoring, than doing the quadratic formula and doing complete the square. If you are not good at factoring, then you might want to avoid this one, right? Assess here. If you are not a good factorer, just don't factor when it says choose your method. If you are good at factoring, that should be the first thing you always try. Always look to see if you can factor a quadratic, because if it factors, it's a lot faster than going through the quadratic formula. Okay. All right, so let's look at option 2. I have x squared plus 6x minus 11. So like I said, let's see if I can factor this, right? That's our first option. So if I look at, I have a leading coefficient of 1. I have 1 times negative 11. So I need 2 numbers that multiply to negative 11 and add to 6. It's not going to factor, right? So I'm stuck now. Factoring is not going to work between the quadratic formula and completing the square. You can, but I'm going to tell you which one to choose here. I'm going to suggest that you use completing the square on this one. You can always do quadratic formula. However, completing the square is going to be nicer here because of this fact. I'll tell you why, and then we'll solve it. Completing the square, I'm going to abbreviate it, CTS, is easiest when the leading coefficient, or I guess I'll say this, when B is even. What is B? The middle number. When the middle number is even, complete the square works the best. So B needs to be even, and the leading coefficient A should be 1. However, on your quiz today, you did a complete the square and the leading coefficient wasn't 1. But you were able to divide everything by A, and then the middle term was even. So you could say, or, when all terms are divisible by the leading coefficient A. So, again, I know there's a lot there, but complete the square is easiest in general when it just says plain x squared out front, and the middle number is even. If you have that, do complete the square. It's going to be faster than the quadratic formula. Or, if this was a 2 and everything else was divisible by 2, complete the square is pretty easy then as well. So let's review complete the square. This should be a piece of cake if you aced your quiz. I guess we'll see when we do this problem if you know what you did. So where do I have to start here when I complete the square? I add 11. So when I add 11 to both sides, what do I replace that 11 with? A box. A box. So if you got that part, you at least were good. If you knew how to move the number over and replace it with box, that's a good step. How do you fill in the box? Half of b squared. So half of 6 is 3, and 3 squared is 9. So 9 goes in both boxes. This side always factors, the left. The left factoring is really helpful because we know it's going to factor into 2 identical factors, so we can skip right to the factor squared. What is the factor going to be? 3. X plus 3. Remember, 3 is always half of the middle number. So if this is what you did on your quiz, you're on the right track so far, and 11 plus 9 equals 20 on the right-hand side. So all we have to do here is take the square root. You get x plus 3. What do you have to put in front of the square root? Plus or minus radical 20. Now, does radical 20 simplify? Yes, what does radical, I'm going to do it over here. Radical 4 times radical 5, which is 2 radical 5. So I'm going to replace this with 2 radical 5 right here. Yes, I move the 3 over, and I always put the negative 3 in front of the plus or minus. Now, here's something that some of us were got some points off on our quadratic formula quiz earlier this week. This right here that I have in the box, this is called an exact answer. Okay, I always want exact answers. I do not want you, unless it says to, which it won't, unless it says to give me the decimal approximation of this, I do not want you to type negative 3 plus 2 radical 5 in your calculator and give me 1 point something. I don't want that. I want this answer. You are welcome to leave it as a plus or minus. Some of you went ahead and did negative 3 plus 2 radical 5 and negative 3 minus 2 radical 5. That's okay too, but that's all you have to do right there. That is an exact answer. If you take the ACT, that's the kind of answers they're going to have in your multiple choice. So might as well leave it in the box. Save yourself a little bit of time here. Don't type it in. Because when you type it into your calculator, when you do that, that is then going to be an approximated answer, not an exact answer. Okay? So that's the kind of thing I want. One more. So we did factoring. We did complete the square. We have 2x squared minus x plus 5. Now, first of all, let's see if factoring works, because that's always where you should start. Because if you can factor, factoring is going to be the best. So here I would do split the middle, if I could factor. So 2 times 5 is 10. Can you think of two numbers that multiply to 10 and add to negative 1? You have 1 and 10 or 2 and 5. No. So this one doesn't factor either. So factoring doesn't work. Let's talk about complete the square that we just went through. Is the leading term 1? No. Is everything divisible by 2? No. So complete the square doesn't work. So this is when you would do the quadratic formula. Now we talked about yesterday, quadratic formula will always work, but it's not always the best choice. Okay, so quadratic formula works best when b is odd. Okay, the b term is odd, and the quadratic doesn't factor. That's when it works best. You can always use it. So I have the quadratic formula on your paper. It's on the board. Let's review. This was the one method that, even though you've done it before, it's just still, some people have some trouble with it. So let's make sure we know what A, B, and C are here. What would A be from this? What's A going to be? 2. What's B going to be?
1.
No, negative 1. And C is 5. That is what's going to go into this quadratic formula. So you start with x equals. You're going to have a big fraction. All the stuff we write down first go on the top, the numerator of the fraction. Sometimes we get the fraction part messed up. We take the opposite of b, which is just positive 1 here, plus or minus a giant square root. Now, especially because b is negative, you need to make sure you put that negative 1 in parentheses when you square it in the discriminant. Minus 4 times 2 times 5. And that whole thing I just wrote down is the numerator. That all goes over 2 times 2. All right, what is under the radical when you simplify that? Negative 38. I had negative 39. Make sure the negative 1 is in parentheses. So that's 1 minus 40. Negative 39. You don't have the negative 1 in parentheses. Oh, I did get the answer. You did. Okay. Does this simplify? Something does. Yeah. There's negative under the radical here. Pulls out. So you should have an I in your answer. That's the only way that this is going to simplify. 1 plus or minus I radical 39 over 4. You can leave it like this. You don't have to split it up into 2 fractions. Just leave it like that. That's the easiest. And that's your answer. Now, those are imaginary. That's why you couldn't factor. You could have done complete the square, but you would have had fractions. All right, does it kind of make sense when you're going to choose certain methods based